So thank you for having me. So let me just say that this is joint with Ricardo de la O at USC and Xiao Han at Bayes. So in this paper, we're going to ask a fairly simple but fundamental question, which is, do price ratios mainly predict future earnings or future returns? So we know from present value relationships that there's a tight link between prices, earnings, and returns. And importantly, it's a quantitative link, not just a qualitative link. So a 10% higher price-earnings ratio means you need to have 10% higher future earnings growth or 10% lower future returns, or some combination of the two. But it needs to be big enough to justify the current price. Now, we're obviously not the first people to study this topic. In the aggregate time series, it's been well documented that price ratios are mainly related to future returns, not future earnings growth. And then in contrast to this, in the cross-section, it's been shown that price ratios are mainly related to future profitability, which is a measure of future earnings, not to future returns. So while there is a value premium, the main quantitative result that seems to come out of this is that differences cross-sectionally in price ratios mainly predict future profitability. Now, this contrast between the aggregate and the cross-section has led to this common view that the market is micro-efficient but macro-inefficient, in the sense that in the cross-section, prices are mainly related to the cash flows and to the underlying fundamentals. Now, surprisingly, despite this previous literature, what I'm going to argue today and what we find is that in the cross-section, we find that price ratios are mainly related to returns, not to future earnings growth. So the cross-section actually looks a lot like the aggregate time series. So in the paper, we mainly focus on 3 different exercises that are all connected by the use of this present value identity. And importantly, we take a lot of care to reconcile each of these results with the previous literature. So I want to show you how each of these fit with these previous findings about profitability or about the cross-section of returns. Now, for time today, I'm going to spend about 90% of my time on the first exercise. I'll touch on the second exercise, and then the third, I'm just going to kind of leave. If you're interested, it's all there in the paper. But I'd rather explain a few things well than kind of run through a lot of results a bit poorly. So first, for decomposing the cross-section of price ratios, we're going to look at decomposing price-earnings ratios as well as price-book ratios. What we find is that future returns account for about 3/4 of all variation in price-earnings ratios. And earnings growth does play a role, but it's a pretty secondary role. It only accounts for about 1/4. If you want to put this into, say, a modeling framework, what we find is that this is generally very hard to match with standard risk premium models. To get the 3/4 of the differences between firms' prices is purely due to risk premia. Generally, it seems to match better with models of mispricing. And then we're going to take a lot of care to reconcile this with the literature on profitability. Then I'll look at decomposing innovations in price ratios and current realized returns. So looking at changes in prices rather than just the level of prices. We find that these are largely driven by revisions to expected future returns, not to expected future earnings growth. And again, we'll reconcile here with Voltanahu's very famous 2002 paper, as well as a more recent Lockstauer-Tetlock 2020 paper on anomaly returns. And then what I won't be covering today, but I'll preview a little bit, is that we look at the implications of these results for return predictability. First, we find that the price-earnings ratio is a stronger predictor of future returns than price-book ratios. In fact, it drives out the price-book ratio in joint regressions. There's a cool kind of dog that didn't bark style argument where we actually show that the lack of predictable earnings growth is strong evidence that returns must be predictable by these price ratios. And then again, we're going to reconcile this with the Kello-Harju recent paper arguing that long-term returns are not predictable across firms. So just before I dive into the details, kind of why does this matter? Why are we going through so many different ways to come at the same problem, and why are we doing so much reconciliation with the past literature? It's because this is a really fundamental question, and if I convince you of this result, it should really change the way we view or model how companies are valued. So the cross-section of price ratios is not justified by future earnings growth. 3/4 of these differences are not explained by future cash flows. It implies that returns are much more predictable than we thought, and it means that for explaining the cross-section of prices, there's a really large role for either mispricing or substantial risk premia. So risk premia that are maybe an order of magnitude larger than what we thought previously. And it essentially just opens up a large puzzle for understanding the cross-section of price ratios. Okay, so for the main exercises here, the data is going to be intentionally fairly standard, so nothing really new here. We're going to be looking at 1963 to 2020. We're going to sort all stocks into the classic value and growth portfolios. Specifically, what we do is each year, we sort stocks into 5 portfolios based on their price-book ratios, and then we track the buy and hold, returns, earnings growth, future price earnings ratio, and future price book ratio. So the important thing is we're not rebalancing. We're just putting them into cohorts and then tracking the future performance of all of these firms. And for robustness, we play with the number of portfolios, and kind of as an interesting technical note, we show a new firm-level decomposition that you can use for these price earnings ratios. Okay, so again, I'm mostly going to focus on the first set of results. I'll look at price earnings ratios, price book ratios, reconciling this with the literature, seeing what this implies for models, and then looking at this firm-level decomposition. So just to start with price earnings ratios, we're going to start essentially with a variant of the Campbell-Shiller decomposition. So we have an approximate return relationship where the one-period return can be approximated as the one-period earnings growth plus a constant rho times the future price earnings ratio minus the current price earnings ratio. And then if you just iterate this equation, you get a pretty familiar relationship where the price earnings ratio is related positively to future earnings growth, negatively to future returns, and then positively to the future price earnings ratio. So the nice thing here is that because we're using earnings growth instead of dividend growth, this relationship holds even for stocks that don't issue dividends. Now, if we take this relationship, you then get a fairly standard cross-sectional decomposition, where on the left you have cross-sectional variation in price earnings ratios must be accounted for by high price earnings ratio stocks positively co-moving with future earnings growth, high price earnings ratio stocks having lower future returns, or high price earnings ratios having higher future price earnings ratios H periods ahead. Now, since I'll be putting up a moderate number of equations, what you can always remember throughout this talk is that green will mean good growth for the expensive stocks. Red will always refer to bad returns. But essentially, high price earnings ratios have to provide good information about future earnings growth or bad information about future returns, or they're just highly persistent and they just don't converge over time. So what's nice about this is that you can simply estimate how much of this, so the portion of the variation for, say, cash flow news, by just regressing future earnings growth on current price earnings ratios. Here, since we're doing it cross-sectionally, it's all going to be with time-fixed effects. So we're looking at relative variation across these two groups. So instead of a variance decomposition, you can also just interpret all these coefficients as just regression coefficients. What does the price earnings ratio mainly predict? Does it mainly predict earnings growth in green, negative returns red, or the future price earnings ratio in blue? Okay, so, just the last note here. To get to the infinite horizon, we're going to use a VAR. All right, so this is the result, because again, it's a fairly simple estimation. So here, in the dotted points, I'm showing the exact regression coefficients when we run this regression at, say, the 5-year, 6-year, et cetera, horizon. So we can run it all the way out to 15 years. And in the dashed lines, I'm showing you the implications from the VAR model, mainly just to show you that the VAR model does a good job of capturing these long horizon relationships, which is going to give us confidence when we use the VAR to get the infinite horizon result. But the main takeaway here is that high price earnings ratio stocks do have higher earnings growth than their peers. So these green coefficients are positive, but it's just not enough to account for much of the variation. It can only explain maybe 10 to 20% of the overall variation. Quantitatively, the much bigger result is that high price earnings ratio stocks have substantially lower returns than their peers. And at the 15-year horizon, it's already enough to account for more than half of all the variation. So already the majority of this difference in price earnings ratios is showing up as low future returns. If we use the VAR and we take this to an infinite horizon, we get that about 79% of all variation is explained by future returns, and 24% gets attributed to future cash flows. Now, let me take this and just do a similar decomposition for price-book ratios. So it's going to be a similar decomposition with just a little bit of a tweak here. So we can write price-earnings ratios in terms of future earnings growth and future returns. So if I just add in one extra term, which is the ratio of earnings to book, then I can just write that the price-book ratio is the earnings to book ratio plus future earnings growth minus future returns. And then you get a similar decomposition where you can look at cross-sectional variation in price-book ratios should be related to high price-book ratios co-moving with higher future earnings growth, high price-book ratios co-moving with lower future returns, but you also get this third component in black, which has nothing to do with the future. It's just the current contemporaneous co-movement between price-book ratios and earnings-to-book ratios. And the intuition here is that while prices are all about forward-looking measures, the price is the discounted value of future cash flows, book is just a backwards-looking measure. It's just a record keeper of how the firm got to where it is today. And so when you combine price with book, you also pick up this backwards-looking component that has nothing to do with future cash flows or future returns, but it's just kind of related to how the firm got here. How high are its current earnings relative to its current book value? And it doesn't really relate to future cash flows or to future discount rates. And what we'll actually find is that this past component is quite large. But the estimation procedure will be the same. We can estimate the cash flow news and discount rate news with regressions. We use a VAR to get to an infinite horizon. And then this past component here is essentially just going to be a contemporaneous covariance. So what do we find here? The first thing I want to emphasize is that this past component is quite large. In fact, it accounts for about 50% of the variation. So to reinterpret that, about half of the movements in price-book ratios have nothing to do with future earnings and nothing to do with future returns. It's all just about book moving around over time, and it's really not predictive of anything in the future. Now, the remaining 50% is predictive of the future, and what do we find it predicts? If you go to a long enough horizon, it does somewhat predict future cash flow growth, but again, this is really the secondary component. The main thing it's predicting is future returns. In fact, negative future returns. So again, what we find is that price-book ratios are a stronger predictor of negative returns than they are of future cash flow growth. Okay, so now, as I promised, I want to reconcile this with the previous arguments that cross-sections of price ratios are mainly related to measures of profitability. and are not largely related to future returns. So, in Fama French, as well as Cohen, Polk, and Voltanahu, instead of studying earnings growth, they look at a variable of profitability, which is just 1 plus the earnings divided by current book. Now, you can also get a similar style decomposition where you can relate price-book ratios to the sum of future profitability minus the sum of future returns. And again, you would also get a very natural decomposition where cross-sectional variance in price-book ratios has to be due to price-book ratios co-moving with future profitability or negatively co-moving with future returns. And in fact, I already showed you what this red term was. I said that this red term accounts for about 40% of the variation in price-book ratios. So you would already immediately get that this profitability term is explaining 60% of the variation. So we completely agree with the previous statement that variation in price-book ratios is more related to future profitability than it is to future returns. So we're not saying that anything they listed was wrong in their results, but I'm going to break down kind of how we should interpret what's driving that profitability result. So the nice thing is that because these two decompositions actually come from the same present value relationship, you can nicely relate future profitability to future earnings growth and the current earnings to book ratio. And the intuition here is simply that there's two ways to have high future profitability. You could either grow your earnings faster than your peers, or you could just start with high earnings relative to book, and then even if your earnings don't grow quickly, you'll still have high profitability compared to your peers. And since these decompositions are all linearly separable, you can actually take this covariance of price-book ratios with future profitability and split it into those two terms. And again, what we found earlier is that this co-movement of price-book ratios with earnings-to-book ratios is quite large. It's about 50% of the variation. And then the remaining 10% is this earnings growth. So it is true, price-book ratios are very related to future profitability, but it's not because they're informative about the future earnings. It's just because they're very related to the current earnings-to-book ratio. And that's really what's kind of driving the separation between these previous results on profitability and our results about future earnings. Now, this is intentionally a very stylized example, but to give you some intuition of how to think about this result, you could consider two firms that have identical future earnings and identical future returns. The only difference between these firms is that firm L has a low book value, firm H has a high book value. This could maybe be due to differences in capital intensity in their industries, something about their accounting standards. The main thing is that it's something that's already happened. It's nothing about the future. It's just based on how they calculated book up to this point in time. What you would then get is that the price-book ratio of the low book value firm will be higher than the price-book ratio for the high book value firm. They'll have identical earnings growth, but the low firm will be more profitable. So what you would find is that the price-book ratio would predict differences in profitability between these firms, but it's not because it's informative about future earnings growth. It's really just informative about the current book value, because both price-book and profitability are scaling by the same variable. Okay, so before I get into what this means for models, I just kind of want to do a midpoint summary here. So the main results I want to emphasize here are that price book and profitability are both related by this current book value, and that actually tends to drive the vast majority of their relationship. If we strip out this book component, what we find is that both price-earnings ratios and price-book ratios mainly predict low future returns, not high future earnings growth. Mechanically, what we find in the estimates is that discount rate news is much larger than cash flow news. But more intuitively, what this means is that the aggregate decomposition and the cross-sectional decomposition actually give pretty similar results in the sense that both are largely driven by future returns, not by future cash flow growth. And this really opens up a big new puzzle, which is what explains the large cross-sectional variation in these price ratios. Why is it that 3/4 of this variation is showing up as differences in future returns rather than differences in future cash flow growth? Thank you. And conceptually, it has to be either significant mispricing or very large risk premia. So let me dive quickly into models. So what we do is we evaluate 6 quantitative cross-sectional asset pricing models. So here I've listed 5 of the 6. I'll kind of hold off on the 6th one temporarily. But we consider both models of risk premia as well as models of mispricing. And what I want to emphasize here is that if we look at the cash flow component, in the data, it only accounts for about 20 to 24% of these differences. But in these models, it accounts for, say, 70 to 100% of the differences. In most models we have, differences in price ratios across firms are largely related to differences in future cash flow growth. And differences in returns are really the secondary component. So in the data, we find that differences in future returns explain 50 to 80%. Most of these models predict single-digit differences. There is an exception here for the Kogan-Papanikolaou paper, where they have very long-term differences in risk premia, and that can actually add up to quite a lot, but it's still only a half to a third as big as what we need. In general, it's hard to write down a model where most of the differences are showing up as differences in future returns. Now, by trying enough models, we do eventually find one that works relatively well, which is the learning model of Llewellyn and Shanken, where people are learning about cash flows, and there's really substantial mispricing, in the sense that price ratios have almost no connection to future cash flow growth, and basically all of it is showing up as negative returns, not due to risk premia, but just because people have the wrong beliefs about future cash flows. Now, given Martin is our discussant today, I'd be remiss if I didn't kind of point out that in a subsequent paper, we really dig into this mispricing versus risk premia point by looking at professional forecasts. And what we find is that these low realized returns on high price earnings ratio stocks correspond to about 1/3 being risk premia, where people actually report that they think growth stocks are safer and they require a lower rate of return. About 2/3 can be attributed to their overly high cash flow expectations. And we find that if you combine a model of learning about cash flows with these Letow and Wachter style duration risk premia, it does a really good job both qualitatively and quantitatively matching the data. So these risk premium models can still be important. You just need to combine them with a pretty big amount of mispricing to get you that extra kick in terms of matching those future returns. Okay, so then the last thing I'll show here is I just want to quickly go through a firm level decomposition. The results are very similar, but it's kind of a nice technical element that we really enjoy from the paper. So for robustness tests, we do a large number of these in the paper. The main ones are we look at a rolling estimate over time. So is this just a recent feature of the data? We consider smooth 5-year earnings as well as dividend growth instead of just earnings growth. We bound how large the approximation errors are, and we look at the role of payout ratios for these decompositions. And then what I'll emphasize here is we go beyond the portfolios and we look at firm level differences. So the big technical issue is that standard decompositions that are based around log terms can't really handle 0 or negative values for earnings. And this is one of the reasons people have been kind of hesitant to work with firm level price earnings ratios. So what we provide here is we look at a new way to decompose firm level price earnings ratios that's based around a pretty simple idea. You can look at the change in a firm's earnings yield, so from t to some point t plus h, and you split it into 2 terms. The first is you hold the price fixed, and you say how much would it have changed if you just changed the earnings. So you do this at the original price and the new price, and you take the average. And then you say how much did the price ratio change holding the earnings fixed, and you just change the price. And again, you do this at the old earnings and the new earnings, and divide by 2 just so everything's symmetric. But it's just a simple statement of the change in the earnings yield partly comes from the change in the earnings, partly comes from the change in price. And you can then nicely decompose this, where you say cross-sectional variation in earnings yields has to be due to high earnings yields stocks having a decrease in their earnings, so this would be the green term, having an increase in the price, or they have a high future earnings yield. So it has a similar flavor of this cash flow component, the numerator, the discount rate component, or the price is moving, the denominator, or this persistent component. So we estimate this out to 15 years, and again, we get that there is some cash flow difference, but it's only driving about 10% of the variation. The discount rate component is about 70%. The remaining 20% would come from persistence here. But to rephrase it, we mostly find that differences in earnings yields are explained by the prices moving to align with earnings, not earnings moving to align with prices. So it's really coming from the price movements here. Okay, so The last thing I'll go through here is I want to quickly go through price ratio innovations and current returns. So whereas the first exercise was really focused on the level of these price ratios and why they're so far apart, why one firm trades at, say, 50 times earnings, whereas another firm trades at 10 times earnings, now we're going to be looking at fluctuations in these price ratios. Okay, so again, you keep reiterating this present value identity, so it keeps showing up in a lot of different forms. So you have that the price-earnings ratio can be expressed in terms of future earnings growth minus future returns. That means that if you have some statistical expectations, this means that innovations to the price-earnings ratio have to be due to revisions in expected earnings growth or revisions in expected returns. Here, this then gives you a variance decomposition where you can look at variation in price-earnings ratio innovations, and you can split it into three terms: revisions to expected future earnings growth, revisions to expected returns, and then 2 times the covariance. To calculate these expectations, we're going to use the VAR model from the earlier exercises because we found they did a good job matching these long horizon relationships between prices, cash flows, and returns. And what we find here is that variation in expected returns is about twice as large as the variation in expected earnings growth. So not only is the level of earnings growth not playing a very large role, fluctuations in expected earnings growth is also not playing a particularly large role. We do find a large covariance term because, again, an increase in the price-earnings ratio is going to positively affect expected earnings growth and positively affect the negative returns. So there is a very strong positive correlation between the red and the green terms here. But the main thing I want to emphasize is just that the revisions in expected earnings growth are not particularly large. Now, that might and hopefully does surprise you a little bit if you know Voltanahu's work. And again, we're not going to say anything there is wrong. In fact, we replicate a very similar finding. So what if instead of price-earnings ratios, you looked at current returns? So then you have that the innovation to returns is equal to the revision in expected earnings growth plus the revision in expected returns. But there's a bit of a tweak here that's important, which is that the earnings growth term starts at j equals 0. The return starts at j equals 1. So if we really want to make these equivalent, there's really 3 terms. There's the current earnings growth surprise in black, revisions to expected future earnings growth, and revisions to expected future returns. Now, what we find is if we now do the variance decomposition, we get that innovations to returns are largely explained by variations in this cash flow component, so the current earnings growth surprise plus the revision to future earnings growth. There's a secondary role for the revisions and very little covariance. So what's driving this difference? Well, we know that this variance isn't coming from the revisions. It's really all coming from the inclusion of this surprise term. So again, we agree with the Voltanahu style result that this surprise plus revision term plays a large role, but we want to emphasize that it's really about current earnings growth, not about knowledge of the future. So this would be consistent with the world where earnings growth is very volatile, so big surprises, but relatively unpredictable. So really no big revisions to expected earnings growth. Okay, so I have no time, so I will just end right here with the conclusion. So the main results we want to emphasize here is that the cross-section of price ratios seems to largely be related to future returns, not future earnings growth. We very carefully try to reconcile this with the past literature. So we're not saying any of these results are wrong, but the implication that the cross-section was somehow very different from the aggregate time series, we think really doesn't seem to be there. The cross-section looks just as puzzling as the aggregate time series. And in general, this should motivate models in which realized future earnings growth is a pretty small part of a firm's valuation. And really, the main component is either substantial mispricing or extremely large risk premia. And I will end there. Thank you.